Rutherford, okay? And he thought that plum pudding model is wrong. Now we are going to see what new model was presented by Ernest Rutherford. In 1913, Rutherford created a new model for atom, and this model is quite different from the model which was put forward by plum pudding. Now, according to this model, what the atom should have, point number one is atom have a central nucleus, okay? We have seen in the experiment that there was a small particle present in the center which was bouncing back the alpha particles or the positive particle when it strike that center. So atoms have a central nucleus according to this model. Point number two, which Rutherford have said, that most of the mass of an atom is in its nucleus. Okay, so we have seen that when the positive particle was striking the center particle, it was bouncing back. So why was it bouncing back? It was bouncing back because there was the mass of the atom present in this nucleus, and due to that mass, which was a dense mass, the particles were bouncing back, or they were deviating, deflecting with a certain angles. Okay, point number three, according to this model, the nucleus is positively charged. So we know that when we bombard the positive particles, some of the particles were deviating. It means that the central particle is basically a positive particles which is deviating the positive particles. Okay, if they were negative particle, so they would have attracted the positive particles. And point number four, which Rutherford said, is the nucleus is surrounded by a big space in which electron move. So we see that the majority of the space of the atom was empty because majorly the particle was passing on straight, and it was going and striking the fluorescent screen. According to the experiment which we have seen, the gold foil experiment, we have observed that when Rutherford strike the alpha particle, the positive particles on the gold foil, so mostly the particle was passing straight, and it was going and striking the fluorescent screen. Okay, very few particles was bouncing back and was striking the fluorescent screen at the back. Okay, and some of the particles were deviating with certain angles. So it means that an atom nucleus is very small as compared to the subatomic spaces, or you can say the extranuclear spaces. So the nucleus is small and the nuclear space is large, and that nuclear space, the electron revolve or the electron move. So this is the model of Rutherford. Okay, Rutherford model and plum pudding model, they're two different things. Now you can see the difference between the Rutherford model and the plum pudding model. Okay, coming back to the screen now, if you have any question regarding this particular model, you can ask so that we can move to the next.
Sir, why did the alpha particle beam bounce back?
The alpha particle were bouncing back because in the center of the atom there was a dense particle. Okay, so whenever that particle struck that dense particle, it was bouncing back because it was not allowing that particle to pass on, because there was a denser particle present in the center. So wherever that denser particle, the nucleus is present, and the particles, alpha particles or the positive particles strike that place, it will bounce back. Okay, so wherever that particle is not present, the particle will move on straight. Is it clear?
Yes, sir. And if the beam was a negative beam, so sir, it will attracted.
It would be attracted. It would have been attracted, but negative beam could not give you the idea because they will not go and strike the you can say the fluorescent screen. That could not give you the idea. That can give you idea for the protons, but it cannot give you idea about the complete nucleus. You can have the idea from that that you can find out the proton. Albert Einstein was a scientist who gave the idea of proton, and according to his model, the negative particle he bombarded, and after that he saw that the negative particles was going and they were submerging on the positive plate. So that was the discovery of proton was something else. But here in the Rutherford model, we are discussing that the positive particles we are bombarding, they are passing on straight, or either they can bounce back. So the bounce back particle means that there is a dense particle which is not allowing these particles to bounce back. to move on. Okay, so they bounce back. Whenever the particles strike the edge of that nucleus, they will deviate with an angle. Okay, and whenever they goes in a place where there is no nucleus, they will pass on straight. Clear?
Okay, sir. Yes, sir.
Okay, so the Rutherford model, we have discussed the different points of Rutherford model. It is a very important model, though there was some lapse and some kind of drawbacks in this model as well. But it was one of the, you can say, quite good and possibly best model to explain atom until now, until 1913. Okay, after that we will study in 1914 and more than 1932 the new models of the atom were basically discovered. But Rutherford model has given us a lot of evaluation, a lot of discovery about the nucleus, about the atom and the structure of the atom. Okay, now let's move to the next. This is the new model. Again, you can see according to this model there are 4 points you can keep in mind. Number 1, atoms have a central nucleus. Number 2, most of the mass of an atom is in its nucleus. Number 3, the nucleus is positively charged. And number 4, the nucleus is surrounded by a big empty space in which electrons move. So this was the model presented by Rutherford in 1913. Let's see a little bit more about this one. Now, explanation of Geiger and Martin model and observation. Okay, the experiment which they have performed. Let's see what Rutherford have explained for them. So you have completely seen the experiment, that what happened in the experiment. Now Rutherford is explaining those points which he observed in the experiment. Number 1, what he says: the positive particles that bounced backwards had hit a nucleus. Okay, so when the particle hit the nucleus, it will bounce back because nucleus is the dense particle. The positive particles cannot pass on from the nucleus, so whenever it hit the nucleus, it will pass back, it will bounce backward. Number 2, the positive particles that travel straight through the foil had passed through empty space between the nuclei. Now we know that there were multiple atoms present and multiple nucleuses were present in them. Okay, so between the nuclei, the one nucleus and the second nucleus, there was a lot of empty space. It means that atom majority space is empty. A very small particle is present in its center. That small particle is known as the nucleus, but the majority of the particle, the majority of the atom is empty, and the positive particles can move straight through them. Okay, these are the 2 points which were explained by Rutherford, and this experiment was performed definitely by Geiger and Marsden, and along with Rutherford. So Rutherford, after observing the experiment, after seeing the result, he explained the points. So the first point which he explained was the positive particles that bounced back had hit the nucleus. Because of that, they have bounced back. Number 2, the positive particles that travel straight to the foil had passed through empty space between the nuclei. So there is a lot of empty space in the atom which is present. Okay, so the positive particles maybe they passed on from there. They can pass from there. Okay. Now Rutherford also told about his work to other scientists, that I have done this work, I have made this model, and all the things which he has performed in the experiment, and after that with the model he has created, he told about that model to other scientists as well. Now Neil Bohr was a scientist who worked a little bit on Rutherford's model as well. So Rutherford model says that electron revolve in the space around the nucleus. Okay, but Neil Bohr said that electron should revolve around the nucleus in particular path. They cannot revolve like in their own. They will have to revolve in a certain path, and to that path Neil Bohr said that this path is known as shell or orbits. So electron revolve around the nucleus in particular shells, in particular orbits. Like you can see in the planets in the solar system, the planet revolve around the sun in the particular manner, in the particular shells. So similarly, the electron revolves around the nucleus in particular shells. These shells are also known as orbits. So this was explained by Neil Bohr. The most authentic model of the atom was given, and the most detailed model of the atom was given by Neil Bohr, which we until now we follow that model. Okay, so this model was given by Neil Bohr, but Rutherford was the scientist who have given the idea that there are the nucleus is present in the cell. Okay, in the atom, the electron is revolving around the nucleus, but he did not particularly say that the electron revolve in the shells. Okay, he said that the electron revolve around the nucleus. Now, how the electron revolve around the nucleus, that was explained by Neil Bohr. By experiment, he performed a lot of experiments, but the experiment of Neil Bohr, the model of Neil Bohr is not given in your book. So whatever is given in your book, we have to focus on that, because Neil Bohr model is basically a mathematical model in which he done a lot of mathematics and calculations. So you will study Neil Bohr models in grade 9. So in grade 8, you are not supposed to study about Neil Bohr's model. Here you have studied about Rutherford model. You have gotten the idea about Rutherford model. In class 9, you have to study about Neil Bohr model as well. So that model will give you an idea that how the different calculations has been done regarding the atoms and regarding its model. Now, if you have any question, somebody's mic is on. Kindly turn off your mic. And if you have any question now regarding the work and explanation which Rutherford had done regarding the medicine and the Geiger model and his work and experiment they have performed. If there is any kind of question right now, you can ask. No question?
सर जो आपने शेल ऑर्बिट्स वाला बताया है वो थोड़ा और एक्सप्लेन कर दें.
According to Rutherford said that the electron moves around the nucleus. Okay, around the nucleus means that around the positive particles, the electron, the negative particles are moving. So this was basically explained by Neil Bohr. He said that electron revolves or moves around the nucleus, but in particular pathways. Those particular pathways are known as orbits or shell. Is it clear?
Okay, sir. Thank you.
Okay. Now let's move to the next topic. Inside the nucleus. Okay. What are present inside the nucleus? We have studied a little bit about J.J. Thomson Plan model. We have studied about Rutherford model. Okay, we have studied Nagaoka's model. Lots of model has been discussed, and the nucleus was discovered by the model which was presented by Rutherford. Okay, so the scientists thought about the nucleus, and they thought that was the nucleus made of particles or not. Okay, they thought that if the nucleus is made up of smaller particles or not. So for that, again, Rutherford collected some evidences, and how he performed the experiment to collect his evidence, he fired some positive particles into the air. Okay. Now the tiny particles were formed in the air. Very tiny particles were formed. Now, what is present in the air? In the air, there are different kinds of gases present, and majority the air is composed of 78% of nitrogen. It means that nitrogen's atoms are present mostly in the air. The air is mostly and densely, you can say, populated by nitrogen atoms. After that, oxygen atoms are also present, but nitrogen atoms are present in the most. So he realized that the tiny positive particles, they normally came of the nuclei of the nitrogen atoms. Okay, so the Rutherford gave an idea that these positive particles which came up from the nuclei of the nitrogen, they are normally what? They are protons. So proton was initially discovered by Rutherford, but after that, these particles, the behavior of protons and the positive particle was described by Einstein. Einstein is the scientist who discovered protons. Okay. James Chadwick is a scientist who discovered neutron, and J.J. Thomson was a scientist who discovered electrons. Remember these 3 points. Point number 1, discovery of electron was done by J.J. Thomson. Point number 2, discovery of proton was done by Einstein. Point number 3, discovery of neutron was done by James Chadwick. These 3 scientists performed number of experiments, and with the help of those experiments, they proved that electrons are present, protons are present, and neutrons are present. Okay. Until now, we were discussing 2 particles, positive particles and negative particles. We knew about the negative particle, that the negative particle is electron. Okay, but we just call the center, that is the positive spare, a positive spare. We didn't know about the proton. So the proton was the initial work was done by Rutherford, and after that an experiment was performed practically in laboratory by Goldstein. That experiment normally presented us the idea that the center of the atom has a smaller particle present. That smaller particle is known as proton. So proton was discovered by Goldstein. Okay. Now, in the year 1920, Rutherford suggested that protons are not the only particles in the nucleus. He suggested that along with the protons, when he performed an experiment, that experiment is known as Rutherford radioactive experiment. So radioactive experiment is not given in your book again. Okay, with the help of that experiment, Rutherford presented 3 kind of rays, or you can say he discovered 3 kind of rays. One was positive ray, second was negative ray, and third was neutral ray. So he said that when a positive particle is present along with a negative particle is present, in the center of the nucleus there is a neutral particle also present. So what the neutral particle is, this question was answered by James Chadwick in 1932. And James Chadwick performed an experiment, and in that experiment he said that in the nuclei of an atom, neutrons are also present and protons are also present. I mean, the positive particles are present over there. We knew about that. But the negative particles were revolving around the positive particle. But along with that 2 particles, there was a third particle also present, and that third particle is known as neutron. So by the year 1932, the neutron were also discovered. So in the year 1920, 1921, proton were discovered. Okay, before that electron were discovered, and after that in 1932 the neutron, the third particle of the atom, was discovered. And then we have discussed that in 1932 a model of atom was presented that was known as modern model of the atom. We discussed in the beginning of this chapter the modern model of the atom. Okay, I hope it's done. If there is any question regarding the inside the nucleus, now you can ask, so that then we can move on.
Sir, can you again tell the names of the scientists who discovered these 3?
I'm telling you people the names of the scientists. Okay, the first scientist, the first particle was discovered, that was electron. Electron was discovered by J.J. Thomson. Okay, the second particle discovered was proton. Proton was discovered by Goldstein. Okay, number 3, third particle, that is neutron. Neutron was discovered by James Chadwick. So these are the 3 scientists, pioneer scientists. Along with them, other scientists also worked, but the majority work, the pioneer work was done by these 3: J.J. Thomson, Goldstein, and James Chadwick. These are the 3 scientists. It almost took them a long time to discover these 3 particles. When these 3 particles were discovered, then it enabled them that the atom is basically a subatomic part. The atom has subatomic particles present in them. And what these subatomic particles are: electron, proton, and neutron. And then they discovered that proton and neutron are present in the center, in the nucleus, and electron revolve around the nucleus in the orbits. So this was a new model which we discussed in the beginning of the chapter. Okay, this model was made after a long struggle. It was not like a model was presented. This model was presented after doing a lot of work, and after when they have worked on, they have performed each and every experiment, then they concluded that a new model of atom can be presented. And in that model, they said that an atom contains subatomic particles. There are 3 of the subatomic particles. One is proton, second is neutron, third is electron. The proton and the neutron are present in the center of the nucleus, and the electron revolve in the shell. That was the new model presented by the scientists. Okay, so it was basically a collective work of many scientists, which we have discussed. I hope that you
Sir,
have understand. Yes.
sir, we have nucleus. Nucleus was discovered by Rutherford. So, sir, neutron is not discovered by Rutherford.
No, neutron was not discovered. Neutron was discovered many years later after the experiment which was performed by Rutherford. Rutherford performed the experiment in 1911 and 1913 and 1920. Okay, and electron were discovered in 1932. So it took a lot of time because it is a neutral particle, and that neutral particle is very difficult to have the idea about experiments. So we can have an idea about the positive and the negative particle. The reason was that the positive particle were present in the center and the negative particle were revolving around. So it means that they were basically controlling each other, but they didn't knew about the neutral particle. That was later on discovered when Rutherford first performed an experiment that is known as radioactive experiment. The radioactive experiment give us an idea about the rays, positive rays, negative rays, and neutral rays. And after that, James Chadwick worked on, and he presented the idea that the center of the nucleus contain the proton as well as the neutron. So both the particles are present in the nucleus center. So that was done almost 12, 13 years later, the experiment performed by Rutherford.
Sir, then who discovered nucleus?
Nucleus was discovered by Rutherford. But he didn't say about neutron, okay? He said about protons. Any other? Any other question from anyone? Good. So it's clear. Okay. Okay, done. Let's see. We have a little bit time, so we can study one more topic as well. Now, material property, topic number 6.4, protons, electron, and the periodic table. Okay, with the help of protons and electron, we present the periodic table in which the elements are present. A lot of elements which we have discovered in chemistry are present in the periodic table. So let's discuss about protons. Okay, now we know we have the idea of the model of the atom right now. Okay, now let that push forward. We have the idea that the nucleus of an atom is made up of proton and neutrons. Okay. Secondly, all the atoms of an element have the same number of protons. For example, if there is an oxygen atom, so all the atoms of oxygen will contain 8 electrons. If there are 100 atoms of oxygen, each atom will contain 8 electrons and 8 proton as well, because number of electron and proton are same. Okay, and all nitrogen atom have 7 proton. It means that if there are 1,000, 10,000, 100,000 atoms of nitrogen, each and every atom of nitrogen will contain 7 protons in them. So there is a particular number of proton present in each and every atom. Okay, that is not going to be changed. So oxygen atom contain 8, nitrogen atom contain 7, hydrogen atom contain 1, helium atom contain 2. It means that there is basically a fixed number of proton present in the nucleus of each and every atom. Okay, there are a fixed number of protons present. That number of proton cannot be different. And on the basis of these number of protons, we have made the modern periodic table. It means if an atom is having 1 proton, its number will be 1. If an atom is having 2 protons, its number in the periodic table will be 2. If an atom is having 3 protons, its number in the periodic table will be 3, and so on. If an atom is having 100 protons, its number in the periodic table will be 100. So there is a position given to each and every element in the periodic table based on the number of protons present in their cell, because each element contains the same protons. So they are placed at one place. Then the second element contains different protons. They are placed in the another, then third and fourth and fifth and sixth, and so on. Even though if we are having discovered 112, 116 elements, so they have their number of protons exactly. We know that this is their number of proton, and based on this number of proton, we place that atom in the periodic table. Okay, that element is present in the periodic table in a particular place. So if hydrogen is placed at 1, it means that hydrogen has 1 proton in them. Okay, if helium is present in second place, it means that helium has 2 protons in it. So each and every atom, remember, each and every element is basically placed in the periodic table on the basis of their number of proton. If 1 proton, the position is 1. If 2 proton, the position is second. If 3 proton, the position is third. If 4 proton, the position is fourth. Okay, so let's see if there is any question regarding this right now. Ask it so that we move on. Any question regarding the number of protons?
Sir, protons can be 100.
It can be 100, it can be 110, it can be 99, it can be 98, depending upon the atom we discuss. There are different atoms in the periodic table we'll discuss. So that atoms, if an atom is having 1 proton, its position will be 1. If an atom contains 100 proton, its position will be 100.
Sir, nucleus and nuclei are the same.
Yes, nuclei mean multiple nucleuses, more than one nucleus. Abdul Hadi, what is 6.3? Okay. A proton, Homera protons, you know, na, they are present in the center of the nucleus, and on the basis of proton, we put electron, we put elements in the periodic table. It means that each and every atom has a fixed number of proton in them. Okay, like for example, oxygen atom is having 8 protons, nitrogen atom is having 7 protons, hydrogen atom is having 1 proton, helium atom is having 2 protons. So each and every element, each and every atom contain a fixed number of you can say protons. Okay, on the basis of those protons, we normally decide that where we have to put a particular element in the periodic table. Abdul Hadi, if you have joined right now, so you can go to the YouTube and I've given you the lectures over there, you can follow them. How can I repeat 6.3 again right now? It's a whole big topic. Okay, let's move to the next now. We have discussed electron. Keep in mind the protons idea which I've given to you, because and further you have to solve some question. I'll give you some question, so you have the idea about proton right now. Okay, whatever we have discussed. Okay, next now. Electrons and atoms. Remember this one as well. The number of proton and electron are always same in an atom. Okay, if for example an atom is having 7 proton, so the same atom will be having 7 electron as well. The proton will be present in the nucleus and the electron will revolve around, they will whiz around the nucleus in the orbit. Okay, the electron occupy shells. The shells are also called energy levels or orbits. It means that, for example, there are 2 shells, so there are 2 energy levels or 2 orbits present around the nucleus. Each shell can hold a maximum number of electrons. So a particular shell, a particular orbit can hold a particular number of electrons, not more than that. Okay, they cannot hold more than those electrons. Like for example, the first shell can hold maximum 2 electrons. Okay, if after the nucleus, the first shell of the electron do what? It hold only 2 electrons, maximum 2 electrons, not more than that. If an atom is having more than 2 electrons, then you will have to the second shell. The second and third shell can hold up to 8 electron maximum. Each shell, second shell and third shell, can hold up to 8 electrons maximum. The fourth shell can hold 18 electrons. Okay, the fifth shell can hold 32. The sixth shell can hold 64. So it means as the number of shell will increase, the number of electron capacity will also increase. So if for example we are having an atom and its atomic number is 10, okay, and I tell you to draw its electronic configuration, it means that to draw its structure. So first of all, you have to draw its nucleus. Nucleus is a positive particle. After that, we are having 10 electrons. Okay, so we will put first shell and we will put 2 electrons in the first shell. Okay, now how much electron left? 8 electrons are left. So we will draw a second shell. And how much electron can occur in the second shell? Up to 8. So we have 8 electron. We'll draw in the second shell the 8 electron. So that particular atom will be having 2 shells of electron and a nucleus that is present in its center. Okay. We represent the shells with the alphabets K, L, M, N, O, etc. We'll start with K. The first shell is known as K shell. The second shell is known as L shell. The third shell is known as M. The fourth is N. The fifth is O. The sixth is P, etc. It goes like that. Okay? Is it clear? Now I'm showing you one thing. You will have some idea. Then we'll discuss if there is any question. See, electron arrangement of the first 18 elements. Okay? This one on the right side here, this one is hydrogen. H is the symbol of hydrogen. You can see there is its nucleus, and this is 1 electron. So 1 electron we have drawn in the first shell. This is helium. Helium, its nucleus, and we have just studied that an atom can hold maximum 2 electrons in its first shell. So helium atomic number or helium proton number or electron number is 2. So when there are 2 electrons, it means that in the first shell we can draw a 2 electron. Okay. Now lithium there are 3 number of electron in the lithium. Li is the symbol of lithium. So you have drawn 2 electron in the first shell and the 1 electron in the second shell. Okay. Similarly, you will have to move on. As the number of electron increases, you will increase the number of shell. Keeping in mind that in first shell you will put 2 electrons, and the second shell you will put maximum 8 electron, and the third shell you will put again maximum 8 electron, and the fourth shell you will put maximum 18 electron, and you will move on like that. Okay, so you will draw the electronic configuration like this. Is it clear? Let's see. Back to the screen. Any question right now? Ask. Time of the period is over. If there is any question, ask it right now.
Sir, does shells contain a lot of space?
The shell contains lots of space. You can say that the shell electron number is basically depending upon if there is first shell, so you will put 2 electron in them. If there is second shell, put 8 electron maximum. If there is third shell, put 8 electron again. If there is fourth shell, put you can say 18 electron. So as you will go further on in the shell, the space will be becoming large. There will be large space then. Okay, as you move on, the space around the cell will become, around the nucleus will become larger. Is it clear?
सर आप सारी पिक्चर्स ना ग्रुप पे भेज दीजिएगा.
Yeah, I will do that. I will do that. Don't worry about that.